Hey there everyone, it's time now to talk about water pollution, and as always we're going to start with a definition. Water pollution is when anthropogenic or natural substances change a water source and make it less able to support human or animal life. So how serious is water pollution? Well, it's a major problem worldwide for sure, but some people actually think that as a whole it is the leading cause of death and disease. That could be from various different sources, but all of these sources come from water. There's an estimated 14,000 deaths every day from water pollution. Many rural Indians have no access to a proper toilet, and 1,000 Indian children die every day from diarrheal sickness. 90% of cities in China have some water pollution, and millions of people around the world have no access to safe drinking water. This is a particular problem in parts of Africa. However, it is, without question, leading to a lot of deaths. So, as we said before, natural water pollution is something that happens. As with all pollution, it can happen naturally, but again, as with all pollution, it's anthropogenic water pollution we're going to spend our time talking about. However, we are by now familiar with the idea that volcanoes and earthquakes can cause natural pollution. They can also cause natural water pollution. Any chemical change in a soil may also cause some kind of change in nearby water sources. A forest fire might lead to a lot of ash being washed into local rivers. Changes in water quality can happen by other spontaneous factors like storms that stir up sediment and algae blooms which can cover the area. And here we can see algae blooms taking various different forms. Sometimes they can actually be quite colourful, quite beautiful in a way, if they weren't slowly killing all the life beneath the surface of that water. Well, maybe not all of it, but they can certainly cause some damage. So overall, we're going to divide all the water on Earth into two main types. Surface water, which is found on the surface and also just underneath it as well, and groundwater, which is found at a much deeper level in what we call aquifers. So surface water and groundwater are linked, but the interactions are complicated and they take place over a long period of time. We're not actually going to talk about groundwater pollution too much. We will come back to it briefly at the end and talk about how serious it can be. We are, however, going to look at surface water pollution, and we can divide this pollution into two different types: point source and non-point source. Point source pollution is pollution that happens at a point. You can see where it goes into the water, and it's a pipe or a drain or some other kind of obvious place where the pollutants come into the water. Non-point source is a little bit different. The pollutants enter over a wider area. They can be washed into a river through the soil, which can go into the river at many different places. In many ways, it's just a categorizing problem. We don't really treat the pollutants very differently once they are in the water. So, point source pollution comes from a pipe or a drain, or, as we said, enters the water at a single point. And here are some different examples of point source pollution. It's easy to locate point source pollution, and they are the most common things that people think of when they think of water pollution. But then there's non-point source pollution. It enters along a stretch of water, as we see in these examples. Agriculture is the most common cause of non-point source pollution, but there are various examples in various industries. Sometimes it's difficult to tell the difference. You can start off with non-point source pollution, and if that goes into a drain or something, it can end up as point source pollution in a different location. So as you can see, this distinction between point source and non-point source is a vague one at best. Something that falls on a wide area could end up being deposited in a specific place. So now we're going to talk about the different types of water pollutant, and there are many different kinds. We could talk about pathogens, which are biological substances. We could talk about parasites, which are tiny creatures. There is some crossover between the idea of a pathogen and a parasite. We'll also cover chemical pollutants, which could be organic or inorganic. And we'll talk about macroscopic pollution, large objects in the water. There's also a problem of turbidity when water becomes unclear, and this can cause issues. And even thermal pollution, the idea that a change in the temperature can be as serious as other kinds of pollution. So pathogens is the first type we'll look at. Any biological substance that gets into the water can be called a pathogen. Pathogens, as we understand them, typically include viruses, bacteria, fungi, and other kinds of microorganisms. There's thousands of different types. Not all of them are harmful, even when we ingest them, but many of them are. Parasites are small creatures that live on or in other creatures and feed from them in some way. There are various different types, but they are typically more complex organisms than pathogens, and that's why we call them something different. Although, as I said, there's some crossover between them. Chemical pollutants are just chemical substances that get into the water, but we can broadly draw a difference between organic chemicals, which are based on the element carbon, so anything which is to do with life or life processes is likely to include organic chemicals. Some organic chemicals do not include carbon, but they are all integral to life. On the other hand, there are inorganic chemicals. Inorganic reactions can be different, but they are still able to affect living things and can be harmful. There's also macroscopic pollution. Now, this is when any large object gets into the water, and it can cause problems for water life in some ways. It also looks very ugly to humans. Macroscopic pollution can go all the way up to extremely large objects like a derelict ship, which can be left in the ocean. Turbidity is simply cloudiness in water. Here you can see particulates in water causing cloudiness. It makes the water dirty and hard to see through. These particles can reduce light in the water, which stops photosynthesis, and this can also get into the gills of fish, blocking them and making it hard for the fish to breathe. Just two of the ways that turbidity can cause serious problems for underwater life. And finally, we come to the weirdest kind of surface water pollution, thermal pollution. Thermal pollution is strange because it doesn't include any damaging substances. The only thing that happens is you change the water temperature. So one example is cold water thermal pollution. Imagine you have a dam like you see here, and below the dam is a river. Now, sometimes it is necessary to let some water out of the dam, and if the pipe that lets that water out goes from the bottom of the lake, then the lake near the bottom is very, very cold. The warm water is at the top where the water is lit by the sun. So if you let water from the bottom of the lake into a river, you're going to make that river much, much colder. And some organisms need a specific temperature to thrive. On the other hand, there is also hot water thermal pollution. Our factories often use water from the rivers to cool their machinery. So the factory sucks cool water out of the river, and then after it's cooled the machinery, it puts that hot water back into the river and raises the temperature, again possibly causing problems for life in there. Even though the hot water is perfectly clean, the factory has not placed any dirty substances in it, but it can still cause problems for life in the river. So as I said, we'll come back briefly to groundwater pollution. Groundwater pollution doesn't happen easily. It's difficult for water to filter down into the groundwater, but it can happen. Imagine you have a truck, maybe a long way from a surface water source, and if that truck has some kind of problem and dumps chemicals into the ground, those chemicals will sink. It might take quite a long time, but it's possible that over time they will sink all the way down to the aquifer. Once those pollutants are in the aquifer, it takes a very long time to come out. We are talking tens, if not hundreds of years. In some parts of the world, water can take thousands or even tens of thousands of years to return to the surface. So pollution in the groundwater may not seem like an immediate problem, but it's a problem that is going to last a very long time. So that's what we will say about water pollution. As you can imagine, there are many specific pollutants that can affect water sources. We didn't talk about chemical compounds in the same way that we did with air pollution. That's all from me for now.